Hello, welcome back. This is part 2 of the types of chemical reactions video. So for this video, you're going to need your periodic table, your types of chemical reaction notes. We're going to start at part 2 on the 3rd page, and something to write with. So when you're ready, let's get going. So last time we learned about synthesis, decomposition, and single replacement reactions. We're going to learn about 3 other types of reactions in this video. So first one is going to be double replacement reactions. So in single replacement, you remember that one element comes in and kicks another element out of the compound, depending on whether it's metal or a non-metal. Double replacement, both are getting replaced. So here you have metal, non-metal, metal, non-metal, and actually the metals are going to switch non-metals. So I like to think of this one, the last one, single replacement was stealing a dance partner. This one's trading a dance partner. So the positive ions of 2 ionic compounds change places to form 2 new ionic compounds. You can also think of it as the negative ions change place. They just switch the one they're with. So for example, here is calcium chloride, CaCl2, plus sodium carbonate, Na2CO3. And what it becomes is calcium carbonate and sodium chloride. So here you can see if we say calcium is our metal, sodium is our metal, you can see that they swap partners. So now sodium goes with calcium's partner chlorine and calcium goes with carbonate. Okay, so let's try it ourselves. And these ones you're not going to be able to predict, again, whether something is aqueous or solid. It really depends actually on how soluble something is in water. So we're not going to worry about that yet. You will get to that when you get to grade 11 and 12 chem. Okay, so here we have lead, Pb, lead 2, and then nitrate and potassium iodide. So if we want to think of it as the lead and the potassium switching places, now we would have potassium, and you might need your chart. Potassium's charge is 1, okay. Nitrate is NO3 and its charge is 1, and then lead is charge is 2, and iodine's charge is 1, so it's going to get a 2. Okay, great. So now we just have to balance it. So lead, remember to keep polyatomic ions as 1 unit if you can. We can here because it appears on both sides of the equation, the products and the reactants. Okay, so I have 1 lead, 2 NO3s, 1 potassium, 1 iodine, and then 1, 1, 1, 2. Okay, so it looks like we're going to want to put a 2 to balance. Let's balance the iodine by putting a 2 here. Okay, and then now these 2 are unbalanced. Not anymore. There we go. Balanced. Okay, now the next one. So this is double replacement. Okay, so to identify it, you'll see 2 ionic compounds on the left-hand side of the equation. There is a special kind of double replacement reaction, and it's a neutralization or an acid-base reaction. So it's a special type of double replacement reaction where an acid, we tell acids because the formula starts with hydrogen, and a base, where the formula ends with hydroxide, OH, react to produce water and a salt. Now, the definition of a salt in chemistry is an ionic compound produced by a neutralization reaction. So when you see a double replacement reaction where one compound starts with H and another ends with OH, you know it's going to make water. They've written it HOH here to show you that it's a double replacement reaction. Obviously, we normally write water as H2O. And then the A and the B come together, so B is a metal, so it's Ba. Metals go first. Okay, so for example, here's sulfuric acid plus calcium hydroxide. So you can see right away starts with an acid, ends with hydroxide. Right away, just write H2O and then see what's left over. And what's left over is calcium and SO4. So you put them together. Okay, so here I have it again, hydrogen, hydroxide. So I see right away, this is a neutralization reaction. I'm going to write H2O. Water is always going to be liquid in these, so you can write your L. Sometimes it's written like that, so you can tell it's an L and not an I. It's like a cursive L. And then what's left? NaCl. And this one's actually, I can see it's already balanced because I have two H's here. Okay, so this is our neutralization reaction. It's a special kind of double replacement reaction where you have to recognize that one is an acid starting with H and one is a base ending with OH. Okay, are you ready for the last one? The last one's called combustion. That word didn't move onto the next page. Sorry about that. I'll just leave it here so you can see it. Combustion. You might have heard this term combustion before. It means like burning things or, yeah, there's going to be some fire going or some heat produced more accurately. So combustion is a reaction of a compound or element with oxygen to form an oxide, a compound containing oxygen. So for example, here is sulfur plus oxygen and it becomes SO2, sulfur dioxide. Here's nitrogen reacting with oxygen to become NO2, nitrogen dioxide. So these reactions are the main source of pollution. So my acid rain example in the last video of sulfur dioxide reacting with oxygen and becoming SO3 so that it can make sulfuric acid later. That's where this is coming from. So sulfur is given off in a lot of like manufacturing as a pollutant, same with nitrogen, and they can become these compounds which can cause acid rain. This should say G also. Now, mostly what I'm going to give you is combustion reactions of hydrocarbons. Hydrocarbon, just like the name implies, is a compound containing just carbon and hydrogen. And these reactions can produce heat and light. So, for example, well, any general equation is going to look like CXHY plus O2. And the products are always the same. It's always going to produce carbon dioxide and water, okay? So in this general equation, X and Y could be any number. It's just how many carbons, how many hydrogens you have. You've seen these ones in balancing. These are the tricky ones to balance. So, for example, methane is a natural gas. It's used in gas stoves. It is a greenhouse gas that comes from the burping of cows and sheep because they have kind of a weird way of digesting their food. So here's methane. And when it reacts with oxygen, which can happen when you like light a match near methane, that's going to give it the small amount of energy it needs to undergo a combustion reaction with oxygen. It makes carbon dioxide and water. This is gasoline like you would find in your car, C8H18 plus oxygen. These are the easiest ones to predict the products for because it's always going to be CO2 plus H2O. But as I mentioned before, these ones can be tricky to balance. I always go in the order CHO. So we have 8, 18, 2, 1, 2, don't get fooled, 3. That's not convenient. So, whoops, let's do carbon first. So let's put an 8 here and see what happens. I should be using pencil in case I mess it up. Okay, so 16, 17 O's now. But my carbons are happy. So now let's move on to hydrogen. If we put a 9 here, then we will have 18 hydrogens. So that's happy. But now we have 16 plus 9 is 25 oxygens. Okay, So what do we do when this happens? You would put a 12.5, and then we're going to multiply all of these by 2. So 1 times 2 is 2. This should be 25. This should be 16. This should be 18. Ta-da! Balanced. You can double check by just coming along here and saying, okay, now that's 16. Now that's 36. Now that's 50. Check my carbons, 16. My hydrogens, 18 times 2, 36. And do I have 50 oxygens? Let's see, I have 16 times 2, which is 32, plus 18. Yes, it's 50. Okay, phew. It's a hard one to balance, but you did it. We did it together. Okay, the last thing is you can have incomplete combustion when a combustion reaction runs out of oxygen. So if you don't have 25 oxygen molecules to react with, this won't actually be a complete combustion reaction. It'll be incomplete. And this produces carbon dioxide and water, but also solid carbon, which looks like soot, like the little black stuff you get on your fingers if you touch something that's been burned, and carbon monoxide, which is a colorless, odorless, and highly toxic gas. This is why if you leave like a car running in the garage, it can poison you because it's going to run out of oxygen and start producing carbon monoxide. So be careful about incomplete combustion. Okay, there are some practice questions for you to try identifying these reactions. And then if you want an extra challenge, you can try predicting the products yourself in the next section. Have fun. Let me know if you have any questions.